How long do you think the longest-lived creature will live? 100, 500哦，张千. Today, we're going to talk about those amazing creatures with long lives. 10th New Zealand, crocodile lizard. This ancient creature, which can be up to 80 centimeters long, has skin covered in crocodile-like prismatic scales and is the only living sphenodontia animal. The New Zealand crocodile lizard can live between 100 and 200 years. In 2008, when scientists deciphered its genome, they found that this guy had a 5 gigabytes super large genome equivalent to 7 times the size of the human genome, which retained the characteristics of primitive reptiles and evolved repeats unique to mammals. Their metabolic rate is only 1/3 that of the average lizard. Their heartbeats are only 7 times per minute, and their body temperature can drop to 5 degrees Celsius during hibernation without dying. Research from Victoria University of Wellington has shown that the organ function of the 100-year-old crocodile lizards is still equivalent to that of human prime in life. There are only about 100,000 crocodile lizards left in the wild today, and a warming climate is quietly changing the fate of this ancient species. Since sex is determined entirely by the incubation temperature, no more females will be born when the soil temperature exceeds 22.25 degrees Celsius. As a result, scientists predict that by 2085 there will be only males left, and this species, which has survived 5 mass extinctions, may end its 200 million years of evolutionary history due to high temperatures. 9th Rugai rockfish. The average lifespan of these bronze-spotted deep-sea dwellers is 205 years, and they are mainly found in cold waters between 31 degrees and 66 degrees north. Adult specimens can reach a maximum length of 97 centimeters and weigh about 900 grams. Genomic studies at the University of California, Berkeley, have shown that there are 137 mutations associated with extreme longevity hidden in its gene sequence. One of the most groundbreaking discoveries is the abnormal activity of the poiprilin gene family, which is an immunomodulatory gene that is highly effective in inhibiting chronic inflammation. While other fish are at risk of cancer in middle age, the Rugai rockfish's DNA repair system is constantly working, like a molecular-level repairman ready to repair cellular damage. Because they live on a cold seabed below 5 degrees Celsius all year round, their metabolic rate drops to extremely low levels, and this physiological slow motion drastically reduces free radical production, making them as youthful as soaking in liquid nitrogen. 8th Galapagos tortoise. As the giant of the reptile class, the adult Galapagos tortoise can reach a length of 5 meters and weigh a record 400 kilograms for a male, which is equivalent to the weight of 3 adult giant pandas combined. As ectotherms, they spend 1 to 2 hours in the morning sunbathing their backs to absorb heat, followed by 8 to 9 hours of slow movement foraging for food, walking at a speed of only 0.3 kilometers per hour, a third of the speed of a human walk. When it comes to breeding, the Galapagos tortoise follows the slow pace to the end. Males do not reach sexual maturity until they are 20 to 25 years old. Newborn hatchlings need to go through 40 years to grow into a standard size. Wild individuals can generally live more than 100 years old, and the captive bred Harriet has set a record for animal longevity at the age of 175. However, this species, which has endured vicissitudes, has also been endangered by human greed. In the 16th century, there were 250,000 tortoises on the islands, but by the 1970s, only 3,000 remained. Poachers piled them up in the cabin as live cans. Thankfully, conservationists have worked wonders through captivity. The Spanish island subspecies has expanded from 15 to more than 1,200, and in 2019, a female was rediscovered on Fernandina Island, which was thought to be extinct for 100 years. Today, visitors can see 5-year-old captive-bred hatchlings on Santa Cruz Island, and the numbers on their backs are not only a sign of identity, but also a symbol of hope for life. 7th Bowhead whale. you'll be blown away by the arched skull, which has evolved over millions of years, with a skull over 30 centimeters thick and an internal honeycomb structure that can withstand the impact of a truck's high-speed impact and easily shatter 60 centimeters of ice. But that's just the tip of the iceberg of its saga. What really fascinates scientists is the code of immortality embedded deep in its cells. In 1993, researchers found fragments of a whaling spearhead from the 1820s in the body of an elderly bowhead whale that had survived for at least 211 years through radiocarbon measurements of the lens of its eyeball. However, this is not yet the limit record, as new research in 2024 suggests that some individuals of bowhead whales may exceed 268 years of age. What is the reason for its longevity? The bowhead whales have special mutations in the ERCC1 gene, and their DNA repair efficiency is 10 times that of humans. Even if the cells divide tens of thousands of times, the chromosomal telomeres can still remain intact, fundamentally delaying the aging process. The second is the metabolic miracle bestowed by the extreme cold environment. In near-freezing seawaters, their metabolic rate drops to 1/5 of that of land mammals. According to the Arrhenius equation, the metabolic rate decreases exponentially with decreasing temperature, which greatly reduces oxidative damage to cells. Finally, there is the Buddhist philosophy of survival, deeply rooted in the genes of the species. They hardly participate in peer-to-peer fights. Females only breed every 3 to 4 years, and calves need to nurse for 12 months. This low-energy, slow life mode keeps the risk of survival to a minimum. Sixth, Greenland sharks. Scientists first became aware of the longevity of Greenland sharks in 2010-2013, when Julius Nelson's team at the University of Copenhagen in Denmark captured 28 females, the largest of which was more than 5 meters long. Since traditional dating methods were ineffective, researchers took a different approach, using the lens of the eye for radiocarbon dating. The results showed that the giant shark was between 272 and 512 years old, with a most likely lifespan of 392 years, nearly doubling the vertebrate lifespan record from 211 years held by right whales. What's even more shocking is that it takes at least 156 years for female sharks to reach sexual maturity, which means they take longer to start reproducing offspring, longer than humans. This creature grows only about 1 centimeter per year and can reach a length of more than 6.5 meters when it reaches adulthood. They inhabit extremely deep, icy waters and metabolize as slowly as hibernating polar bears. American shark expert Jack Music pointed out that the low-temperature environment greatly slowed down the rate of cell division, making the biological clock of the Greenland shark almost stagnant. But the latest research reveals even more shocking truths. Its DNA has 6.5 billion base pairs, twice the size of the human genome. These repetitive sequences, known as skipping genes, are self-replicating and form at least 81 special gene networks, a unique gene repair mechanism that is at the heart of their resistance to aging. Fifth, tubeworm. The tubeworm has a peculiar appearance, a white tube several centimeters in diameter composed of calcium or leathery material secreted by itself, which is both a dwelling place and armor, and a 12-meter long giant individual slowly stretches its gill in the dark depths of the sea. It is worth mentioning that tubeworms have no digestive system at all, and they rely on hundreds of millions of symbiotic bacteria to convert toxic substances such as hydrogen sulfide in seabed hydrothermal fluids for energy, and this unbelievable way of survival allows them to thrive near volcanic craters where even fish cannot survive. Scientists first found a colony of tubeworms that lived for more than 3 centuries in a 3,300-meter deep seafloor crack in the Gulf of Mexico. They grow in a special environment that exudes hydrocarbons, growing only 0.2 millimeters per year, and their slow metabolism creates an astonishing longevity record. What's even more shocking is that even if a tubeworm is bitten by a predator, it can continue to live by shutting off its tail and regenerating it, just like a lizard. Fourth, Arctic clams. When you taste the delicious Arctic shellfish, sashimi at a Japanese restaurant, it may be hard to imagine that the close relatives of this creature can live for hundreds of years. In 2006, British scientists accidentally caught an Arctic clam off the coast of Iceland, which completely rewrote the human perception of animal lifespan. This clam, named Ming, was determined to be 507 years old by measuring the growth marks on the shell. This number means that when Columbus discovered the American continent, it was already born. Moreover, if it were not salvaged by humans, this deep-sea birthday star would still continue to survive. Scientists have found that the average lifespan of individuals in the cold waters of the Arctic clam can reach 300 years, and some even exceed the 400-year-old mark. This bivalve creature of the Arctic clam family has a distinctive black-brown oval shell that can grow up to 13 centimeters in size, with dense concentric growth patterns that are as recognizable as tree rings. They are buried in sediment at depths of 8 to 400 meters for life, with only 2 siphons sticking out for feeding and excretion, and this minimalist way of survival is the secret of their longevity. Arctic clams feed only briefly each year in the summer and go into a dormant state in the winter, where their metabolic rate drops to freezing. What's even more amazing is that they have the survival skill of anaerobic respiration, which can survive in a completely hypoxic environment for 7 days, and some individuals have even created a miracle of life for 24 days. More than 15,000 tons of Arctic clams are harvested every year in the Northwest Atlantic, 15% of which are over 100 years old. Third, black coral. Black coral belongs to the subclass black coral, which is known to have 230 species in 42 genera in the world, and is widely distributed in deep-sea areas from the warm waters of the western Pacific Ocean to the Mediterranean. Its uniqueness is first and foremost reflected in the rate of growth. The trunk is only slowly thickened at a rate of 4 to 35 microns per year, which means that it would have taken 1,000 years to grow in diameter by 3.5 centimeters. In 2009, scientists discovered through radiocarbon measurements that certain populations of black corals had been growing for 4,265 years, meaning that these deep-sea dwellers were already there when the ancient Egyptians began building the pyramids. Unlike shallow sea corals that rely on photosynthesis, black corals do not have symbiotic algae in their bodies and rely entirely on plankton for energy. The structure is composed of discontinuous bone needles covered with small defensive spines and a longitudinal section of concentric rings that resemble tree rings, making it resistant to deep-sea pressures. Today, however, the long-lived black coral is on the verge of extinction, with the $4 million illegal black coral trade seized in the United States in 2011, exposing the deadly threat of market demand to this ancient species. Second, Antarctic glass sponge. The shape of the Antarctic glass sponge resembles a delicate glass handicraft, and the whole body is composed of silica bones woven from glass fibers with a 3-dimensional grid structure of only a few microns in diameter, showing a translucent texture and shimmering blue in the shimmering light of the deep sea. Scientists have found that each glass fiber in the structure presents a checkerboard-like lattice supported by 2 parallel diagonals, which is lighter and stronger than the trusses commonly used in human architecture, and can withstand the impact of deep-sea high pressures and ocean currents. Regarding their lifespan, different research data have yielded different results, but they are all equally shocking. Early biologists believed that a 2-meter tall Antarctic glass sponge could take 10,000 years to grow, but in 2022, Yule culture revealed that the samples had survived for about 11,000 years. What's even more shocking is that the 2024, the 21 longest living animals in the world study pointed out that the lifespan of Antarctic glass sponges may exceed 15,000 years. The longevity of Antarctic glass sponges is inseparable from the environment. The perennial low-temperature environment of -2 degrees Celsius in Antarctic waters greatly delays the metabolism rate. The regenerative mechanism of continuous renewal of stem cells in the body almost stopped the aging process. As filter-feeding organisms, they are highly effective at capturing organic detritus from seawater and can enter metabolic dormancy even during periods of food scarcity. It is worth mentioning that the central cavity of the Antarctic glass sponge is often inhabited by the shrimp. After the young shrimps enter the sponge body, they are permanently sealed as the sponge grows, forming the most romantic symbiotic relationship in nature. The prisoners rely on the water filtered by the sponge to obtain food until the end of life. First, immortal jellyfish. Do you believe that there are truly immortal beings in the world? Beneath the blue waves of the Caribbean Sea, a transparent creature the size of a fingernail has turned human. Perception upside down, the immortal jellyfish known as the Peter Pan of the sea. This tiny life, which is only 4-5 millimeters in diameter, breaks the strict law of birth, aging, sickness, and death in nature with its own unique survival mechanism, and realizes the miracle of going back in time. The story begins in 1988 in a laboratory in Genoa Bay, Italy, where a careless student left an immortal jellyfish in a petri dish. A few days later, when he was about to process the dead specimen, he was shocked to find that the bottom of the container had quietly sprouted a polyid-like larvae. The jellyfish carcass had not only not decayed, but had degenerated into a more primitive life form and regrown. This accidental discovery unveiled nature's most astonishing code of life. When starved, injured, or reproductive, the immortal jellyfish can reverse mature cells into totipotent stem cells through cell meta-differentiation, and degenerate into polyps attached to reefs as if pressing the button to reset life. This reverse growth process is like a human being who suddenly changes back into an embryo at the age of 80 and then redevelops into a baby, theoretically, in an infinite cycle to achieve true immortality. What's even more amazing is that each newborn polyp has completely inherited the life code of the mother and can develop into a jellyfish with reproductive ability again at any time. In other words, as long as they are not preyed upon by predators or encounter extreme environments, their life clock will never come to the end.